In Topic 6 of Module 1, what we're going to be doing is going through a series of word problems in which we will develop equations, and in some cases two equations, to solve what they're asking. So step 1, of course, is to read and reread. Determine later what letters we might use. Formulate our equations. Solve them and check them. So we'll give you a few moments to read this over and see what we come up with. Okay, we have two types of tickets that are on sale. Here we can use the letter C for the number of children's tickets and A for the number of adult tickets. So this leads to our first equation of C plus A, and they sold 420. Now our next equation will be, what is the cost of each child's tickets? $5. And the adult tickets, $8.50. And the revenue from this will be $3,325, and I'm going to add 2 decimal places, because as we go to solve this, what technique might you use? Well, get rid of the decimals by multiplying each term by 100. And then we don't have to worry about decimals anymore. Now, we could use substitution, in which we solve, let's say, for C. C will equal a negative A plus 420. Now we're going to take this value for C and put it where C is. So our next equation would be 500 times a negative A plus 420. There's our C replacement through substitution, plus 850 A equals this. Now we're not going to solve it at this time, but you can see now we have just one letter. Once we find out what A is, we would then substitute it here and solve for C. Let's go on. Now in letter B, this is very, very similar to what we just did in letter A. So take a moment to read it. You want to decide what letters can we use for the variables that will help us in solving. Well, we have quarters. We could use Q for quarters and D for dimes. So the total number of quarters plus the number of dimes equals 75. Now, what's the value of quarters? Well, 25 cents. What's the value of each dime? 10 cents. and altogether the value was 1335. So there are our two equations, very similar to the previous one. How do we solve it? Well, get rid of our decimals by multiplying each term by 100. Just moving it over two places. Now, we could use substitution, but if you multiplied this equation by a negative 25, we'd have a negative 25q, a positive 25q. These would cancel out. In fact, let's do this one. So negative 25, I'll put it right under here. Negative 25q. Negative 25 times d is a negative 25d. And a negative 25 times 75. I'm using my calculator. I got a negative 1875. Now when I subtracted that from this, I got a negative 540. Now when I divide both sides by a negative 15, and here you have to be careful of your signs, I get d equals 36. So if I have q plus 36 equals 75, substituting my d value here, I get q equals 39. So I have 36 dimes and 39 quarters. Very similar to how we did the previous example. We'll give you some time now to read about the coffee blend. Again, this one is very similar. I think the first thing you want to do here is define the letters you want to use in your example. And over here we have a Columbia blend that we can call C. And up here we have a house blend that we can call H. And we know that the amount of pounds of Columbia blend, C, plus the amount of house blend, H, that's going to equal 10. And again, in a similar fashion. Now, what does the Columbia blend sell for? $6.50. And the house blend, $4.25. And we want to end up with a mixture that costs $4.70. And how much of this mixture will we have? 10 pounds. Again, this is the beauty of algebra. And now, what technique? Well, I think what you'd want to do is get rid of your decimals by multiplying each term by 100. And then up here, if you multiplied this equation by a negative 650, then the C's would cancel out. Remember, it's each term. And going through these steps carefully, you would solve then for the h's. Once you find the h, you subtract it from 10. That will give you the c's. Here we're just showing you how to set up the equations and then using your skill to solve. Now in this one we have a total amount of stock that someone wants to invest. So this would be 5,000, and we want to say how much of this 5,000 will we invest at 5%? Well, we can say that would be X. And the other portion at 10% would be Y. So the amount of that 5,000 and the other amount would equal the 5,000. So there's your first equation. Again, very similar. Now we want interest, so we're going to earn 5% of this plus 10% of this and we expect our interest to be this much. Step 1, or whatever step, get rid of the decimals. Now again, you'd have to add the 2 decimal places here so that when you multiplied every term, you would be able to move it over 2. Again, you can use substitution, or you could multiply this equation by, yes, a -5 every term, and then the x's would cancel out. Letter C is very similar. You have 2 types of solutions, a 40% that we will call X, a 90% that we will call Y, and again it's going to be X plus Y. This is the number of liters of 40%, the number of liters of 90%, and that's going to be 10 liters. Now the concentration of the 40% plus the concentration of 90% will equal what you want to get in the end, a 70% of 10. And once again, to get rid of our decimals, multiply every term by 100. And if you wanted, you could use substitution, or multiply this equation by what? So that these would cancel out. If you said a -40, you are correct, but it would be every term. Add them up, and then of course you're solving for y, and if y is 7, subtract 7, x would be 3. Okay. Now in number 3, we change things a little bit. We're going to have 2 parts of the equation, but actually we're just going to use 1 letter. So basically we're starting a trip and we're going upstream. Then we are returning downstream. And since we're talking about rates and hours and distance, we're going to use the distance formula. Distance equals rate times time. Now, what do we know about the distance here? Can you see that we know the distance is the same? So in a sense, we have distance equals distance. That is, rate times time will equal rate times time. So let's start to fill this in. Now the time for 1 is going to be 3 hours. So time times rate, and the returning 9 hours, and it would be times rate. Now, do we know the rate? Do we know this rate? Well, no. We're going to call that R. That's her rate in still water. But it's faster when she's going with the current, and that speed of the current will increase her rate by that amount, which is 2. So this is her rate, unknown portion, and then the rate of the current that we put in parentheses to include it as one item. Now, returning is going to be against the current, so her rate in still water minus 2, and there's distance. Time times rate. Time times rate. And we then get 3R plus 2 equals, I'm going to put this in parentheses, 9 times R minus 2. And again, it's important that it's in parentheses. So let's just do this one. So this is 3R plus 6 equals 9R minus 18. Transpose the 3R, we get 6R. Transpose the negative 18, we get 24. And we get R is 4, dividing both sides by 6. So what is Daphne's paddle rate in still water? 4 miles per hour. So again, it took time to think of the strategy, had to pick out a formula that was useful, develop that distance was equal. You knew the time, you didn't know the rate, but we knew the speed of the water, and by enclosing it in a parenthesis, we had time times rate. Time times rate. The distances were the same. All right. Now our next example, again, we're going to use distance. So let's help you set it up a little bit here. We have a train that's going to go this amount of distance. This other train's going faster and then eventually catches up. We want to know how far they travel when they catch up. And again, so our distances are the same. So we're going to use distance equals rate times time. And we're going to use the concept of distance equals distance. So we know this train is 80 and this train is 100. That's its rate. Now what do we know about the time? Well, for one, the faster train, let's call that the unknown time, t. Well, the slower train went this amount of time plus how many hours more? And the answer is 4. So there's our equation. 80 times t plus 4 equals 100t. Distance equals distance. Rate times time is distance. So we'll work this one out too. 80t plus 320 equals 100t. Subtract 80 from both sides, we get 20t equals 320. Divide both sides by 20. We get t equals 16. But notice when we look at the answer statement, or the question, how far from the station will they meet? We have an answer that is time. Here's a case where we have to take this time, put it in either of our equations. We could put it in this one. Time is 16, and we get distance then equals 1600. Ah, that's the answer. Again, this was sort of a two-stepper. We had to find what the time was here and then apply it in the distance formula. Okay, we have a few more problems that we'll look at, but basically this is the end of the 3rd week. Next week we do 2 lessons and you should be taking your test if you want to stay on track for finishing the course in 1 semester.